Hello, and welcome to How to Do Math with Alex Garian. Today, we are going to be looking at this lovely polynomial, f of x equals negative 15x to the third plus 27x to the second plus 54x. And we are going to be discovering quite a few things about this guy today. So, let's jump into it. So right now, this dude is in standard form, and so there's already one thing we can find, which is the end behavior. So if we look at our first term over here, negative 15x to the third, we're going to use our leading coefficient and our degree to find the end behavior. So the first thing we look at is our leading coefficient, and we see if it's a positive or a negative number. And because negative 15 is negative, that means that as x is going to infinity, y will be going to negative infinity. And then if we check out our degree, it is 3, which is an odd number. And when the degree is an odd number, that means that the end behavior will be the opposite on the other side of the graph. So then we have, as x is going to negative infinity, y is going to be going to positive infinity. All right, and so the rest of this stuff, we have to factor this bad boy for. But luckily, there's already quite a few things we can take out of this dude, which is a negative 3 and like an entire x. So that's fun. We can take out 3x, and that leaves us with 5x to the second plus minus 9x, because we took out the negative, minus 18. So now we have a quadratic here, and we can solve this by grouping. So if we take the product of our leading and our constant, we get negative 90, and we bring negative 9 down here. So the factors we're going to use are 6 and negative 15, because 6 times negative 15 is negative 90, and 6 plus negative 15 is negative 9. Grab that out of the way, and we got 3x, 5x to the second, minus 15x, plus 6x minus 18, and you take out the 5x, you got x minus 3, then you take out the 6, get x minus 3 again, leaving you with your total factored form of negative 3x times 5x plus 6 times x minus 3. Ta-da! Okay. So now that we have our final factored form, we can hop over here and figure out what's going on with the graph of this function. So because it's degree 3, we know we're going to have 3 zeros. And we can find all of those zeros using the factored form of this thing. So negative 3x equaling 0 is just going to be 0. If we set 5x plus 6 equal to 0, we get 6/5. And if we set x minus 3 equal to 0, we get x equals 3 for our 3 zeros. And so all of these are real zeros, so they are all going to be x-intercepts on the graph. So that's 0, 0, 6/5, 0, and 3, 0. And we don't have to do any math to find our y-intercept because 0, 0 is already on the graph, and because it's a function, we know that it's only going to touch the x-axis one time. So the y-intercept is 0, 0. All right, and now we're going to graph it. So I'm going to pop the factored form up here so I can make some room over here. All this is gone. All right. So here's our coordinate plane. So first thing we want to do is we want to graph all our intercepts. So we know that we have 0, 0. We know that we have 6/5, 0, and 3, 0 as points on our graph. And then to find the rest of it, we want to graph our end behavior. So we know that as x is going to infinity, y is going to go to negative infinity. So at the end, we do something like that. And then as x goes to negative infinity, y goes to positive infinity. So this end is going to be going like this. And now we just have to connect the points and make sure we hit that little guy in the middle, go right through here. So our graph is going to look something like that. And because we have, y going to infinity and negative infinity, and x going to infinity and negative infinity, there's no stopping or anything, we can use that to find our domain and range, which is all real numbers for both domain and range, because if you put in any value for both x and y, you're going to come up with n or more than one answer. So that's fun. So we write our domain as x is the element of negative infinity to infinity, and our range as y is the element of negative infinity to infinity. And now we have found so many things about this polynomial. Yay! I hope you enjoyed how to do math with your host Alex Gary, and I'll see you again next time.